All right, so when we have two exponentials that have the same base, it's really easy. You just set the exponents equal to each other and you solve it like any other equation, right? But you have some of these that you just don't have common bases for. Like, is there a common base between 17 and 4? No, there's no number that you could multiply. Like, it's not like you could go, oh, 17 squared equals 4 to the 5th. Like, they just don't have any of those numbers in common. So you can't give them a common base. And you'll see there's even more complicated ones besides this. They just don't have a common base. And truly, this is the easier way to solve these than the common base thing. So really, this is the easiest way to solve these exponentials. It doesn't really matter if you can find a common base or not. This is actually really easy. So you know how we can multiply both sides by the same number, or we can divide both sides by the same number, or even square both sides? Well, guess what? We can take the log of both sides too. Okay, so what would happen if we take the log of both sides? We have log of 17 and then log of 4 to the x, okay? Well, what do we know about exponent rules, or log rules? We can take this x and we can move it out front. So now we have log 17 equals x log 4. Okay, now we want to get x all by itself, so we're going to divide both sides by log 4. And we get x equals log of 17 divided by log of 4. Now, since I used the common log base 10, or if I had used ln, we actually have a button on our calculator for this. So this is when our calculator is going to come in handy. So I'm going to pull up our calculator. And if you don't have a calculator at home, email me. Remember, I have a way for you to get a free emulator right now during the COVID-19 crisis. So if you don't have your calculator at home for one reason or another, or you just need this, make sure you contact me if you haven't already downloaded it. Okay, so to do this, we're going to push log of 17, parentheses, divided by log of 4, parentheses, okay, and we push enter, and we get 2.043731421. Now remember, our calculator keeps lots more digits than it actually shows, so there's actually more digits inside of our calculator, so we don't want to just like write this number down and say, oh, that's the answer. We want to keep this number in our calculator, and we want to check it. We want to see, does this work? Okay, so we're going to say 4 to the, and then we're going to choose that number. See, I arrowed up and I push enter. 4 to that number equals 17.0000001. Now my calculator is a terrible rounder, remember, so anytime I see 17.0000001, it means 17. So there you go. This is our answer. And remember, in Algebra 2, we're going to use 3 decimal places. So 1, 2, 3. So you're going to write this down as 2.0437. And that's it.